Lesson 2.8, literal equations. Our essential question is, how do you solve a literal equation? We have one new vocab word today, literal equation. A literal equation. You've seen literal equations before, you just may not have heard that vocab word tied to what they are. Literal equations are formulas or equations that have multiple variables in them. When I say formulas, some of the formulas that should be familiar to you would be like A equals LW, or maybe A equals BH, or A equals pi r squared, formulas like those. So if you ask yourself where you've seen those before, I'm sure you can probably think about them. The A stands for area, and those are area formulas for different types of figures. I could even do base times height divided by 2, and that would change it to a different figure. Now what we are going to focus on is we are going to use the same skills that we've used when we've been solving our equations in chapter 2. So we are going to be keeping our equation balanced. We are going to be adding, subtracting, multiplying, or dividing on both sides of our equation to solve, and we are going to be isolating the variable. The variable that we isolate is going to be different on each problem. This problem, for example, says solve for b. So that means that this letter b is the one that we need to get by itself. So our answer should look like b equals something. Okay? Now, over here, you see a couple of different equations that we learned how to solve already in this chapter. So to try to help you think about how to solve this, we're asking you the question, which problem does this look similar to? I'm pretty sure that you could pick out the second one, that it looks similar to that second one, 15 equals negative 5j. Now think about how you solve 15 equals negative 5j. You would solve it by dividing the negative 5 on each side to leave the j by itself. So we're going to do the same thing on this problem, use the same idea. So to get that b by itself, b is multiplied by h, so that means I need to divide to get rid of that h on the right-hand side. And now I'm already done. I'm already done. b is all by itself, and what it equals is the area divided by the height. So if you are looking for the base of a rectangle, and you know the area and you know the height, you would just have to divide them to get the base. The next formula, this is a triangle now, the area of a triangle. What does this look similar to? Probably looks similar to this second one right here because it's got a fraction in it. And the fraction takes up one entire side of our equation. Now, how it's a little bit different is this actually has a fraction with an extra h in the numerator and a 2 in the denominator. So I want you to think about what we did when we had a fraction, like say 2/3 next to our variable, and that was equal to another number like 10. To solve a problem like that, with 2/3 next to the x, we multiplied by something called the reciprocal. So that is going to be the key here. I need the b to stay all by itself. So I'm going to multiply by 2 over h to eliminate the 2 and the h in one step. So, cancel out my 2's and my h's. I can drop a 1 under my a, and now I've got the b by itself, and it's going to be equal to 2 times a divided by h. That is my final answer. B equals 2a divided by h. So the base of a triangle is equal to 2 times the area divided by the height. So what we're doing is we're rewriting formulas so that they're solved for a different variable. These first two started out that they were solved for the area, and we solved them instead for the base. When you're working with formulas, you really never know, as you get further in math and science, you really never know which one it is that they're going to ask you to find. So it's important to be able to use a formula in multiple ways. Okay, our third one. V equals LWH. This is the volume of a box or a rectangular prism. I am going to go with this first equation as being most similar to it because the length, width, and height are all being multiplied together. So to solve this, you can actually divide, since they're being multiplied, you can divide by the L and the H at the same time and cancel both of them out because the inverse of multiplying is dividing. So now we are left with W equals the volume divided by length times height. Our next equation, you may or may not know this one. This is the perimeter formula for the perimeter of a rectangle. Perimeter equals 2 times the length plus 2 times the width. The problem it's most similar to now is down here on the bottom, where we've got a two-step equation, because on this problem, we are trying to get the W by itself, and if you take a look at where I've got my train tracks, the 2W, we have a plus 2L also on that side. So the married couple part is the 2W. So we're not going to do anything with that first. It's the plus 2L. So we are going to subtract 2L on both sides. Subtracting 2L on both sides, I bring down my W and my 2. Now, P subtracted by 2L, there's nothing that you can do. There's nothing that you can do that's a shortcut there. They are not like terms. Remember, like terms have to have the same variable part. So P and L are different variables. You've got to just write them side by side then, P minus 2L. Then, the last step, the second step, you would divide by the 2 that's in front of the W. So divide by the 2, and you've actually got your answer. It doesn't look pretty. W equals P minus 2L, all divided by 2. Remember, we're not trying to eliminate any of the variables that are in the problem. We are just trying to solve for a different one. So all of those variables and numbers might still be present in your solution. Okay? So don't feel like you're going to get a nice number like x equals 2 or y equals 5. Literal equations are different. If they gave us values to plug in for a couple of the variables, you would get a number for your answer. But we don't have any values to plug in right now. We're just manipulating the formulas. Okay, next one. This one's very similar to the last one. So I believe it's similar to this one on the top again. The M is the variable that we're trying to isolate. So 4M is going to be our married couple. So that means I'm going to need to get rid of this 3N by adding it. Again, I do not have like terms on my right-hand side over here. So I am just going to write it as 8 plus 3N. That's it. You cannot put them together. It's not 11N. It's not 11 anything. Okay? Leave them separate. Then divide by your 4, and you are done. The 4's cancel out. So M equals 8 plus 3N, all divided by 4. The next one, this one's really, I think, very tricky because you're always inclined to take the variable x and distribute it because it's outside of the parentheses. We do not want to distribute it though because we are trying to isolate that x. So I want you to look over here at the top equation where we had negative 5 times j, this problem is actually similar to the negative 5 times j. We have two things being multiplied on the right-hand side. One of them happens to be the w minus 13, and then the other one is the x. So to solve this problem with the negative 5j, we divided by the negative 5 coefficient. So we are going to do that same thing on this problem, and we are going to divide by the w minus 13. We're going to treat it as a coefficient to our x. So remember, a coefficient is like a number in front, so we're going to treat it just that way. So if I divide on both sides by w minus 13, I don't even have to have the parentheses there, but I divide by it because they were being multiplied, and the inverse of multiplying is dividing. I will have isolated my x, and it is equal to v divided by w minus 13. Very tricky, very tricky. So do not distribute, because if you distributed the x, you would have two x's in your problem, and that's not what we want. We only want one because we're trying to isolate it. So to isolate, divide by w minus 13 instead of multiplying by it. It was being multiplied. To undo that, you divide. Okay, this next one is a big fraction. So this one looks like the third problem over here. To solve a big fraction, remember our first step was to clear that fraction by multiplying both sides. So the denominator number is 5. I'm going to multiply by 5. So that fraction is gone. Now, when I bring down my problem, I have k minus 2 still. But on the right-hand side, I get 55j. 55j. Then I just need to add my 2 on both sides. So now k equals 55j plus 2. 55j plus 2. So, not like terms, leave them separate. Another problem. This one looks like the second one over here, where we had that fraction. So to get the x by itself, my married couple is 2/3 x, so I need to subtract away the v first. So that leaves me with 2/3 x equals w minus v. Not like terms again, so we can't do anything about those. Now the tricky part. When I multiply by this reciprocal, I am going to need parentheses on my right-hand side because you have to multiply everything by 2/3, not just one of those variables. On the left-hand side, I only have to write it to multiply and cancel out, so I get x equals on the left-hand side. But on the right-hand side, the 2/3 is being multiplied by w minus v. If you wanted to distribute it, you could, but I prefer to just leave it in front of my parentheses. So, tricky. On this problem, you had to subtract the v first, which gives you w minus v, but then when you multiply both sides by the reciprocal, that means everything on both sides. So be careful and use parentheses around the w minus v. Okay, is this our last one? Yes, our last one. Okay, on this problem, what's tricky about this one? You see variables on each side. So this one is similar to the bottom problem over here. And when we've got variables on both sides, we want to eliminate one of them. I always go with the smaller one if possible. So negative 13x, I'm going to eliminate by adding 13x. So now my resulting equation would be, let's see, 21x plus 11v equals w. So 21x plus 11v equals w. All right, now my married couple is going to be my 21x. So subtract 11v on both sides. That leaves leaves me with 21x equals w minus 11v, and then I can divide everything by 21, and I am done. So, x equals w minus 11v, all divided by 21. That's it. Hopefully you're getting the hang of these. We will spend a second day on these types of problems. So the first day we have some book problems for you to try out. And then the second day, you can write your summary now. These are your book problems, so 1 through 4, 8 to 15. And then the second day in class, we'll be going over all of the homework questions that you need. And then we have a versatile that we're going to do for some extra practice on these because we know that they're very tricky. These types of problems though, honestly, you will see literal equations in science class in the future. So when you're in high school and you take a class like chemistry, you'll be working with a ton of formulas and you will be solving them for different variables and figuring out the effects that different variables have on each other. So I know it looks tricky because we're used to just solving for x, but it's really good to get some practice now because you'll see a lot in the future.